Have you ever looked up at the night sky and wondered what's out there? Scientists are always asking that same question, and now they have a powerful new tool to help them find the answers. This incredible tool is the James Webb Space Telescope, or JWST for short. It's like a super-powered eye in space that can see farther and more clearly than ever before. A huge team of scientists from all over the world, called the Cosmos Collaboration, used the JWST to create something truly amazing. They pointed the telescope at a patch of the sky for over 250 hours, collecting faint light that has been traveling for billions of years to reach us. This wasn't just a quick peek, it was a long, patient stare into the depths of space. What they created is called the Cosmos Webb Map, and it is the biggest and most detailed map of the universe ever made. Imagine trying to make a map of your city, but instead of streets and buildings, you are mapping galaxies. And these aren't just any galaxies, many of them are among the oldest and most distant we have ever seen. Making this map was a massive undertaking, requiring the telescope's advanced instruments, which can detect infrared light. This type of light is invisible to our eyes but is perfect for seeing through cosmic dust and peering back into the very distant past. The result is a breathtaking image that gives us a new window into how our universe grew up. This project is a huge step forward in our quest to understand our cosmic origins. Before the JWST, we had other powerful telescopes like the Hubble Space Telescope, which gave us incredible views of space. But the JWST is specially designed to look back in time, almost to the very beginning. By capturing light from the early universe, scientists can see what galaxies looked like when they were just forming after the Big Bang. The Cosmos Webb project isn't just about finding the one farthest galaxy, it's about seeing the entire neighborhood of galaxies, understanding how they live together, and how they changed over billions of years. It's like finding a photo album of the universe's baby pictures. The information gathered by the JWST is more than just a pretty picture. It is a treasure trove of data that scientists will study for years to come. The team carefully processed all the raw data to create clear images and a detailed catalog. This catalog lists nearly 800,000 galaxies, each one a collection of billions of stars, planets, and mysteries. Each point of light in the map tells a story about a different place and a different time in the universe's long history. This project helps us piece together the grand story of how everything we see today came to be, from the first stars to our own galaxy, the Milky Way. It's a monumental achievement that opens up a new era of discovery. To understand just how gigantic the Cosmos Webb Map is, let's compare it to another famous space picture. You might have heard of the Hubble Ultra Deep Field, or HUDF. For a long time, it was our deepest look into the universe, revealing about 10,000 galaxies in a tiny patch of the sky. It was an amazing accomplishment. Now, imagine printing that Hubble image on a regular sheet of paper. At that same scale, the new Cosmos Webb Map would be a giant mural stretching 13 feet tall and 13 feet wide. It covers an area of the sky about the size of 3 full moons, which is huge for a telescope this powerful. This shows the incredible leap forward we've made in our ability to survey the cosmos. This massive map looks back an astonishing distance in time. Because light takes time to travel, looking far away in space is like looking back into the past. The Cosmos Webb Map lets us see about 13.5 billion years into the past. Our universe is thought to be around 13.8 billion years old. So we are seeing galaxies as they were when the universe was just a toddler, only a few 100 million years old. This is like looking at a timeline that covers almost the entire history of the universe in a single view. We can see galaxies in their infancy, their teenage years, and their adulthood all at once. It's an unprecedented view of cosmic evolution in action. The goal of this project was not just to find a few distant objects, but to map out the cosmic web. The cosmic web is the large-scale structure of the universe, made of long filaments of galaxies and dark matter surrounding vast, empty regions called voids. Think of it like a giant, glowing spiderweb stretching across space. By mapping such a large area, scientists can see how galaxies are distributed within this web. They can see the crowded city-like regions where galaxies are clustered together and the quiet, empty countryside in between. This context is crucial for understanding how the environment a galaxy lives in affects how it grows and changes over time. With a catalog of nearly 800,000 galaxies, this map is an incredibly rich resource. Each galaxy has its own story, and scientists can now study them in large numbers. This allows them to do statistics and find patterns that would be impossible to see with just a few examples. They can compare young galaxies to older ones, or galaxies in dense regions to those in empty voids. It's like being a sociologist for galaxies, studying how they behave and interact within their communities. The sheer scale and detail of the Cosmos Web Map provide an unparalleled data set for asking and answering some of the biggest questions in astronomy today. When scientists began to analyze the data from the Cosmos Web Map, they found something completely unexpected. They were looking at the very earliest moments of the universe in the first 500 million years after the Big Bang. According to our best scientific theories, this was a time when the very first stars and galaxies were just beginning to light up the darkness. Scientists expected to see a few small faint galaxies starting to form. Instead, they found that the early universe was much more crowded than anyone had predicted. There were roughly 10 times more galaxies in this early period than our models said there should be. This discovery was a huge surprise and has sent ripples through the scientific community. It's like expecting to find a few small campfires, and instead finding a landscape full of bright bustling cities. The galaxies they found were not only numerous, but some were also surprisingly large and bright. Some of these early galaxies had already formed 1 billion times the mass of our Sun in stars. This happened within just 400 million years of the Big Bang, which is incredibly fast in cosmic terms. It challenges our understanding of how quickly galaxies can assemble and start forming stars at such a furious pace. These findings raise new and exciting questions about how the universe works. Our current theories of cosmology, which describe the formation of the universe, might need some major revisions. How did these galaxies grow so big, so fast? Did the first stars form differently than we thought? Was there more fuel for star formation available in the early universe than we calculated? These are the kinds of questions that get scientists really excited because they point to new physics and new discoveries waiting to be made. It's a sign that the universe is even more interesting and complex than we imagined. The new map also revealed things that were completely hidden from the Hubble Space Telescope. For instance, the JWST's infrared vision allowed it to spot supermassive black holes at the centers of very distant galaxies. These are monster black holes, millions or billions of times the mass of our Sun, that were already active in the early universe. Finding them adds another layer to the puzzle. How did these giant black holes form so early on? Did they help the galaxies grow quickly, or did the galaxies help the black holes grow? Answering these questions will help us build a more complete and accurate story of our cosmic history. One of the most wonderful things about the Cosmos Web project is that the science is for everyone. The team behind the map, co-led by scientists Caitlin Casey and Jehan Kartaltepe, believes in democratizing science. This means they want to make sure that anyone, anywhere in the world, can access and use this incredible data. After spending 2 years carefully processing the raw information from the telescope, they made the entire dataset public. This includes the stunning images and the massive catalogue of nearly 800,000 galaxies. Now, anyone with an internet connection can start exploring this new frontier of the universe. This open data approach is changing how science is done. It allows researchers from smaller universities, students, and even curious members of the public to participate in the process of discovery. A student in a classroom can now work with the exact same data as a top scientist at a major research institution. This collaboration on a global scale can lead to faster breakthroughs, as more eyes are looking at the data and more minds are thinking about what it all means. You never know who might spot the next big clue or ask the question that leads to a new understanding of the cosmos. It's a truly powerful way to accelerate learning. The work of the Cosmos collaboration is far from over. This first data release is just the beginning of a long and exciting journey. The scientists plan to continue collecting more data with the JWST, peering even deeper into space and time. Their next steps involve using a technique called spectroscopy. This will allow them to confirm the exact distances to the most ancient galaxies and study what they are made of. They will look for elements like carbon, nitrogen, and oxygen, which are the building blocks of stars, planets, and even life itself. This will help them understand the chemistry of the early universe. As we stand here on June 16, 2025, we are looking out at a universe that is more vast and mysterious than we ever knew. The Cosmos Web Map has rolled back the curtain on the cosmic dawn, but it has also shown us how much more there is to learn. Every new discovery seems to bring with it a new set of questions, but that is the beauty of science. It is a continuous adventure, with each answer leading to a deeper mystery. Thanks to the James Webb Space Telescope and the dedicated work of scientists around the world, we can all be part of this incredible exploration. The universe is waiting, and its secrets are ready to be unveiled.